In this video, we're going to talk about how to find the expected value of a discrete probability distribution. And the expected value is the same as the mean. It's kind of what's expected to happen if you did the same thing many, many times. Per trial, what would you expect to happen? So here's our first procedure. So it says a roulette wheel in Las Vegas. There are 38 numbers to choose from. You pay $5 and choose one number. If that number comes up, you win $175 and you get your $5 back. On average, what are your expected earnings or losses each time you play? Okay. So if you win, you get a profit of $175. So in our X column, you're putting how much you win or lose. And if you win, it'll be a positive amount of money. If you lose, it'll be negative. So if you lose, you've lost your $5 bet. Okay, now since you're picking one number out of 38, your probability of winning is 1 over 38. I don't know why I didn't make an 8. And your probability of losing, well, there's 37 other numbers that would make you lose out of 38. So the expected value, now to find the mean, remember you take the sum of x, p of x. So we would take 175 times 1 over 38 plus negative 5 times 37 over 38. You could also put these in L1, these in L2, and do 1 var stats L1 comma L2 like we did in the previous video. So here 175 times 1 over 38 plus negative 5 times 37 over 38. So we get, if we round to the nearest cent, we'd have negative 0.26. So what we're saying is, on average, you would lose 26 cents each time. Now, we know that for each individual turn, that's not even possible. You're either losing $5 or you're making $175. So this is saying in the long run, if you did this many, many times and you averaged it all out, you'd be expected to lose about 26 cents each time. So number 2 says, a 21-year-old man just bought a 1-year, $100,000 life insurance policy for $250. Based on the U.S. National Center for Health Statistics, this man has a 0.9985 probability that he will still be alive after 1 year. On average, what is the expected value of this policy? So the variable X is going to represent the net gain or loss. So if he lives, he's losing the amount he paid for the life insurance policy. So he's losing $250. If he dies, his family gets the $100,000. But when we talk about the net, we would take $100,000 and subtract the $250 he paid for it. So net, they're making $9,900 and $700. Sorry, I put too many. No, we're good. Okay, $99,750. Now, the probability that he lives, as we're given in the problem, is 0.9985. The probability he dies would be the complement of that, would be 1 minus 0.9985. So 0.0015. So we're going to find the expected value just like we did above. We're going to take the sum of x, p of x. So we'll take negative 250 times 0.9985 plus 99,750 times 0.0015. Oops. So we see that the mean is negative $100. So on average, each customer loses $100 per policy. So that means that the company is gaining that $100 per policy. So if we want to then think about what is the break-even cost of a policy for the company, so if the company didn't want to profit, right now the company is profiting $100. So they sold it for $250, and if we take away how much they're profiting, that means their break-even point is $150. So if they wanted to just break even, which wouldn't be the point of an insurance company, but if they wanted to just break even, they would need to charge, in this situation, $150 per policy. So we're going to look at one more example. So it says, a general contractor knows from past experience that a particular project has a 50% chance of being done on time, earning him a profit of $30,000. So that's the first kind of possibility. So if he's on time, he profits $30,000, and there's a 50% chance, so we'll put 0.50. He also knows there's a 30% chance that the project will be done 1 month late, and his profit will be only $10,000. So 1 month late, he still profits, he gets $10,000, and there's a 30% chance of that. He also knows there's a 20% chance that the project will be finished 2 months late, and he will lose $15,000. So 2 months late, he loses, so we'll make that negative $15,000, and there's a 20% chance of that. So our expected value, we're going to do just like we've done before, so 30,000 times 0.5 plus 10,000 times 0.3 plus a negative 15,000 times 0.2. So we see that his expected profit is $15,000. So on average, he'll profit $15,000 per job.